Welcome, everybody. It's a very short talk, so I will start. And I will be talking about science in software engineering. And I will start by telling you a few stories from science world that are inspiring to me and make me think about projects that I'm working on and projects that I hear about. And the first story will be about Opportunity. And Opportunity is a rover that was sent to Mars in 2003. And when this mission was planned, they assumed it would be there for 92 days. Someone decided that spending all these millions of dollars for this mission is worth this 92 days. But the truth is that this rover is still there 11 and a half years later, and it's still working, sending data back and doing some pretty cool science. And the question here is, how do you build robot, machine, wherever, in a way that it can last over a decade on another planet? It's pretty amazing, right? The second story will be about New Horizons. And New Horizons is a probe that we sent about 10 years ago to Pluto to take some fancy pictures of this dwarf planet and to perform a few other experiments. And there are few interesting things about actually two interesting things about this mission. The first thing is that with this kind of projects, you launch it and you pray. You cannot fix it in the meantime, right? There is no servicing team on the way that can fix it. You can send like software patch, which probably takes ages. You can run some diagnostics in the meantime, but that's it. Can you imagine making one push to your repository which constitutes of whole system and then wait 10 years until you can know if it's working in production? Right? It's like strange. We're not get used to things like this. And the other interesting thing about this project is that the total cost of this mission was $720 million. And you may say, well, this is a huge number, a lot of money, right? But if you compare this number to the cost of some IT projects that are around us, it's not so big. So for example, the major IT initiative at Polish Social Insurance Agency costed already $800 million, and no one knows how much it will cost in the end. And this is just putting some data that we have in forms into computers. This is not rocket science, right? Whereas New Horizons is actually literally rocket science. The last story is a bit different, and it's about understanding the universe. And it's about the Large Hadron Collider, which is, they say, particle collider, but I like more particle smasher. And it's the single biggest machine ever built in the world. And the whole facility around it is the biggest and most complex experimental facility ever built. And there was around 10,000 people working on this project, and it costed $4.5 billion. I can't even imagine how much that is. But you cannot put a price on the understanding of the universe, right? And these 10,000 people, they were coming from over 100 different countries, and there were hundreds of universities helping with this project. And it took them about 10 years to build it, but it's 21 years since the project was approved. And the question here is, well, I saw teams that struggle with 2 time zones and teams that are scattered across the ocean. And how you execute a project where you have people from over 100 countries, which lasts for 10 or 20 years. And what all these projects that I mentioned, these missions have all in common is that they were executed by scientists. And scientists, they have this approach where any theory, every statement has to be backed by empirical data, measurements, and they will reason about it before they will make decision. And of course, there are also examples of projects like this in IT. And I will talk about two of them. The first one is LMAX Exchange. And the LMAX Exchange is kind of trading platform. And they started with traditional approach where they built the multi-threaded application on Java platform and then realized it's not gonna to work. And why? Because they couldn't handle enough requests per second, the latency was too high, and they had to redesign the whole system. And they took this approach where they question every decision they made, starting with architecture. As a result, we have a new architecture called LMAX. Going through patterns, they even came up with a new pattern which we call disruptor. It's more like data structure. And going through the simple things like, in this case, is this data structure, linked list or stack, whatever, the best solution? Is this the most performant way to write this algorithm? And they would measure everything and decide based on the measurements. Because they said that we're like developers, we like to use wherever is in our head. Like, I know linked list, I will use linked list, right? But until you measure, you don't know if it's the best solution. The second project I want to talk about is more like company, is Netflix. And Netflix is a company that has this system built using microservices architecture. And they were doing microservices before cool kids knew what microservices are. And there are two things about Netflix. First thing is that whenever they need something, they will try things that at the top of the shelf. Does it work for us? No. Okay. Let's run a study case. Can we configure it in a way that it will work for us, or can we change it in a way that it will work for us? If not, they will build something from scratch. And once they build it, they would release it as an open source project. And there's just a few examples up there of Netflix open source projects, and I guess there is no one in the world that can comprehend all of them at once. The second thing about them is that experimentation is built into the core of their operation. So at Netflix, if you push something to the repository, it will be automatically deployed to European data center. It will be deployed during the night when people do not watch movies. Then the change will be measured, like the metrics will be, certain metrics will be measured against your change. And if it's all good and it's not changing KPIs when compared to previous version, it will stay there till peak hours. And then if it's all good, it will be deployed to one coast of the US, history repeats, and then to next coast. And again, the experimentation and measurements, it's built into core operation of this company. And what I see nowadays when it comes to technology selection is that people often follow fads and temporary trends or use cool kids tools. And you may say, well, interesting, but how do I distinguish fads from thoughtful tendencies? And how do I distinguish temporary trends from trends that actually are taking IT forward? Or cool kids tools from proven, tested, and production-ready tools? And well, my suggestion is to use this scientific approach, where you gather empirical data, measurements, you apply reasoning to that, and this way you investigate things and acquire new knowledge. And it sounds a bit fog, but try this next time when you face the decision. First, select a few technologies that may be good for you. Then build few prototypes for each technology. Then measure metrics that matter to you. And for some, it will be performance. Simple. For others, it can be something more vague, like time to production, how fast I can change the code I just wrote. It's maybe a bit difficult, more difficult to measure it, but still you can do this. And once you have measurements and data and facts for every single prototype and every single technology, then try to reason about it and select one of them. And this choice will be probably the best for your project and for now. It doesn't mean that it will be, the best choice forever and for every project. Value measurements and the facts over opinions, and try to, be honest with yourself, because everybody has its favorite technology. And it may be the best for the project that you used to work on, but it may not be the best for the project that you work on now. And don't let your ego drive decisions. And the last is share your findings. What I want to see is more articles which go along the lines, we had this decision, we selected these technologies, we built these prototypes and made these measurements. These are results, and ultimately we made this decision because of this and that. And less like technology wars, where cool kids are shouting at each other and screaming whose technology is better. And I could have a full-time session on each of these points, talking about how to build prototypes or how to select the first list of the technologies or how measure things and how to reason about the results. But to sum up what I just said, I would like to paraphrase my favorite series and say that to boldly go where no man has gone before, do your science. Thank you.